In this problem, there is given an array of distances with positive numbers and negative numbers. The positive number indicates the movement to the right, and the negative number indicates the movement to the left. The task is to find the farthest point from the origin that one can travel with a given list of distances. For example, they are given a distances 2, 1 and -2, and according to test cases, we have to consider the each subarray at each traversal. For example, in the first traversal, we have to consider a single subarray of 2, and in the next traversal, we have to consider both the elements, which means we have to consider the first subarray, means 2, 1, and in the third traversal, we have to consider the subarray 2, 1 and -2. So in the first traversal, the person starts at the point 0 and moves to the right of 2 units. So the current position is 2 and the farthest position is also 2, and c equal to 2 and farthest position is equal to 2. And now in the second traversal, we have to consider the subarray, which is 2, 1, and now we have to travel from the current position. So the one travels from 2 to 4 by adding 2 to the current position, and now the farthest position is 4, and the next element is -1, so he has to travel back 1 unit. So now the current position is at 3, so have to update the current position. And in the last traversal, we have to consider the whole array, which means 2, 1, -1 and -2. So he is at the point 3. Now he has to travel 2 points to the right, which is 5, and now the farthest position is 5, and farthest position is 5, and now he has to travel 1 unit left and also 2 units left. So now current position is 2. The task is to print the farthest position in the distances. So the final output is the final output is 5. And again we have to consider the another case. If the farthest point is at the left, we have to return -5. For example, if he is traveling, the farthest point is at somewhere at the x, which is in the left, we have to return -x, which indicates it is at the left to the origin. And now let's see with the code. First we have to initialize an array A, and then the current variable with 0 and the farthest point, which is the farthest variable with also 0. Here I created a new variable n equal to 1 because to find whether the final output, the final farthest point is at left or right. Now I written a loop which runs from 0 to length of a, which means if the length equal to 3, it runs 3 times. And in the inner loop, j runs from 0 to I plus 1. For example, if the array is 2, -1 and -2, in the first traversal, it considers only the first element, and in the second traversal, it considers both the elements, which is 2 and -1, and in the third traversal, where I equal to 2, it considers 2, -1 and also -2. For this case, I took 2 loops, and for each iteration here, the current gets updated by adding the jth element. For example, in the first iteration, initially current equal to 0. In the first iteration of j, Here z equal to 0 at first. So a of z means 2. So current equal to current plus a of j, which means current equal to 2. Now we will compare current element and the farthest point. If the current element is greater than the farthest point, we have to update the farthest point with the current. And now in the first loop, the current is at 2, which means it travel 2 units, and the farthest point is also 2. And now in the second iteration, which means I equal to 1 and z travels from 0 to 2. Now j equal to 1, the current equal to 4, because it traveled 2 units from the current point. And again we will compare the current element with the farthest element, and we'll update the farthest element. Likewise, we will run the 3 traversals and check for whole array. But this code doesn't work for every case, because when we consider all the negative numbers in an array, for example, in the given array, there are elements like -1, -1, -1. In the first traversal, the person travels to 1 unit from the left. When we compare, now the current element is -1. When we compare farthest element and the current element, the farthest element is still 0, because in this case, the farthest element never gets updated. So to eradicate this problem, we have to take absolute value of the current element to compare. So now when the array is -1, -1 and also -1, when the current position is at -1, it will check irrespective of the sign, which means it checks whether 1 and 0, and now far will update it with 1. Likewise, when we use absolute value, the negative distances also get compared here. And now the final case is, we have to print the farthest point whether it is left or right. If the farthest point is at the left, we have to print minus of some value, or if it is at the right, we have to print the positive value. So to achieve this case, I used an variable n equal to 1. It checks whether the current variable is at the negative position or positive position. If the current variable is at negative position, which means it is in the left side of the origin, so n gets updated to the -1. So at the end of the loop, if the n equal to -1, then which indicates that the farthest point is at left position. So simply we will just print farthest point into n, which means if the farthest point is 5, we will just multiply with it with n. So final output is -5.